this lesson, we are going to review applications of derivative using exponential, logarithmic, and trigonometric functions. Our first example is writing the equation of the tangent line to the graph of y equals e to the power of x2 minus 2x at x equals 2, at a point whose x-coordinate is 2. If we plug 2 into the original function, y is going to be e to the power of 4 minus 4, which is e to the power of 0, 1. The derivative of the function is 2x minus 2 e to the power of x2 minus 2x. Derivative of e to the power of f of x is f prime of x e to the power of f of x. The slope of the tangent line is 2 times 2 minus 2 times e to the power of 0. That's 4 minus 2, 2. To find the slope of the tangent line, we plug in the x-coordinate into the derivative. We know slope and point. The equation of the tangent line would be y minus y1 is 1, equals m 2 times x minus x1, which is the same as y equals 2x minus 3. Our next example is finding the interval of increase decrease and concavity of function y equals x minus line of x. We know domain of this function is all positive real numbers. Line of x defined is x is greater than 0. The derivative of the function is 1 minus 1 over x. Derivative of line of x is 1 over x. Derivative of x is 1. We use subtraction rule, and the derivative is 1 minus 1 over x. If we set the derivative to 0, we find out x equals 1. For x between 0 and 1, derivative is negative. If we plug in 1 over 2 into the derivative, we see the derivative is negative. And when x is greater than 1, derivative is positive. Therefore, when x is between 0 and 1, the given function is decreasing. When it is more than 1, it is increasing. 1 and 1, notice that line of 1 is 0, is the local minimum on the graph of the function. The second derivative of this function is 1 over x2. Derivative of 1 is 0. Derivative of 1 over x is negative 1 over x2 times negative is 1 over x2. It is greater than 0 in the domain of the function. This means the given function is always concave up. From 0 to positive infinity is concave up. Our next example is working with a sinusoidal function. Let's assume an object is moving on straight line and its position at time t is s at t equals 2 sine of pi over 2 times t minus 1 when t is in second and s is in meter. We are looking for velocity and acceleration of the object at time t. We know velocity is the derivative of the position function. Derivative of sine of u, sine of f of x, is f prime of x cosine of f of x. Therefore, derivative of the given function is pi over 2 times 2, which is pi cosine of pi over 2 times t minus 1. Acceleration is derivative of the velocity function. It's going to be derivative of cosine. We need this formula. Derivative of cosine of x is minus f prime of x sine of f of x. Therefore, v prime of t is pi times pi over 2, pi over 2 over 2, times negative sine of pi over 2 times t minus 1. Notice that in finding both derivatives, we used constant rule. Derivative of c times f of x is c times f prime of x. Derivative of 2 times sine of pi over 2 t minus 1 is 2 times derivative of sine of pi over 2 times t minus 1. Similarly, we treated pi as a constant when we took the derivative of velocity function. Our next example is finding the interval of increase and decrease of function y equals sine of x plus cosine of x, when x is between 0 and 2 pi, one period of the function. The derivative of the function is cosine of x minus sine of x. Derivative of sine of x is cosine of x. Derivative of cosine of x is minus sine of x. If we set the derivative to 0, sine of x and cosine of x are equal. That means tangent of x is 1. X is either pi over 4 in the first quadrant, or in the third quadrant, pi plus pi over 4, which is 5 pi over 4. X starts from 0. At pi over 4, derivative is 0. 5 pi over 4, derivative of 0, and 2 pi. Between 0 and pi over 4, let's pick a random number, pi over 6. Cosine of pi over 6 is root 3 over 2. Sine of pi over 6 is 1 over 2. Root 3 over 2 minus 1 over 2 is positive. Therefore, derivative of the function is positive when x is between 0 and pi over 4. Between pi over 4 and 5 pi over 4, we choose pi over 2. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. Therefore, for x is between pi over 4 and 5 pi over 4, the derivative is negative. If we choose a number between 5 pi over 4 and 2 pi, let's say 3 pi over 2, we see the derivative is positive. Cosine of 3 pi over 2 is 0, and sine of 3 pi over 2 is positive. Therefore, for x is between 0 and pi over 4, the given function is increasing. For x is between pi over 4 and 5 pi over 4, it is decreasing. And for x is more than 5 pi over 4, it is increasing. Pi over 4 and root 2 is a local maximum. 5 pi over 4 and negative root 2 is a local minimum. Notice that sine of pi over 4 is the same as cosine of pi over 4. and both of them are root 2 divided by 2. Sine of 5 pi over 4 and cosine of 5 pi over 4 both are negative root 2 over 2. In the third quadrant, both sine and cosine are negative. Thanks for watching.